staying so cold like this in lots and lots of years?
Yeah, it's a case of lots and lots of years.
Ooh, yeah, that's what I was thinking.
Because, okay, somewhere along the line you have a sheet coming that's got your story problems on it. So, and we will work through these. There will probably be some of them on this sheet that we probably won't do, but you'll have a good share of them, what does happen with that. 7.4a is looking at proportions. And proportions are just like proportions have always been. In a proportion, you set them up as A over B equals C over D. To solve these, you take A times D is equal to B times C, because within your proportion, what you happen to have in there is that both of these are written as a fraction, and each of these within your fraction end up being equal to each other. So this side is the same as this side if you have what's called a true proportion. And so that true proportion is the pieces that, of course, come together with that. So if we put 2 over 3 is equal to 10 over 15, is it a true proportion? So if I take 2 times 15, will that equal 3 times 10? And I hear out there somebody said, yeah, because 2 times 15 is 30, and 3 times 10 is also 30, and so therefore we know that that is a true proportion, and a true value comes out of it. Now, in a basic math class, when you do these, you'd have just the numerical parts, and within this, any one of these areas can be missing, and so you would end up solving that and figuring out what it would happen to be. In intermediate algebra, they start looking like so, and really what it is we have two rational values that are ending up being equal to each other, okay? Now when we look at this, and we look at these pieces that are in here, we learned back in, I guess it was 7.1a, that there's certain things these can never be. So what can x never be in this problem? Oh, if it's a -5, I can put it in because a -5 times 5 is a -25. All right? Be careful with those, because really what you're looking at here is x can never equal 0, right? Because if I put 0 right here, 5 times 0 is 0, and I cannot have 0 as my denominator. So always keep that in mind as we go through and we start looking at things that have equals in here. And so pay attention to what x can't be. So then how do I solve this? Well, I solve it just like I did up above, so I'm going to take x minus 2, and I'm going to times that by 3x. I'm going to take 5x times 5, or times 6, sorry, and get that piece. So now I need to multiply all my parts together. So 3x times x is 3x squared. 3x times a -2 is a -6x. Go to the other side, 5 times 6 is 30x. So then what I need to do is, because of this equals, this has become what's called the quadratic. And back in chapter 6, 6.6 is where quadratics are at. And when we looked at quadratics in 6.6, we solved them. We solved them and found out what x could be. And so to do this, I need to get it set equal to 0. So set equal to 0. Now, how do I know that's got to get set equal to 0? Because of that equal sign. Okay? So minus 30x from both sides, and I get 3x squared minus 36x is equal to 0. And so now if I take that and I factor it, so now what we want to do is factor this. So if I factor it, what comes out? A 3 and a x, yes. So 3x comes out, leaves me with x minus 3 into 36 is 12. Set each piece equal to 0, so 3x equals 0, and x minus 12 equals 0. And so when I do that, what happens? Well, if I divide by 3, it's up here, divide by 3, I get x is equal to 0. What did we say when we first started this problem? X could never equal 0, so I can't have that for a solution. The other one, I'm going to add 12. So I get x equals 12. And so that would be the solution that makes both of my pieces that I had in my original problem to work out correctly. And so if I check it, we can put 12 back in. 12 minus 2 over 5 times 12 should equal 6 over 3 times 12. So let's see if we get our correct answer. 12 minus 2 is 10. If I cancel, 5 goes into 10 twice, 5 goes into itself once, so I have 2 over 12, then 2 and 12 will cancel. Leaves me with 1 over 6. The other side, 6 and 12 will cancel, so that also leaves me with 1 over 6, so 12 would be my correct solution. Okay? Questions on that one? I'm working it out? Yep, that would be your answer, is just simply x equals 12. Now, if this 0 piece in here would have come out to be x equals 4, then you would have had 2 answers. You would have had 4 and 12. And in Hawks, you separate those. You would separate them with a comma between them, and you'd put them on your in your Hawks. But of course, this one only had the answer of just 12. So when it asks you for what the answer is, you just type in 12. Okay? Questions? All right, let's take a look at some more of these guys so you get an idea of what to do with them. So here's another one. If you have 7 over x minus 2 is equal to 5 over x. So what are we going to end up doing first with this thing? Oh, as I look at it, it's a proportion because I got an equals in here, so everything should be great and fantastic with that piece. So all I simply need to do is take 7 times x is equal to 5 times x minus 2. Now before I finish solving it, what can x never equal? What could it never equal? See, now in here, Mary Jo, that's where you'd want to look at this piece. The other one you're saying it could have been a negative 5. This is the one that it could be it couldn't be a 2, or what else can it ever be? And if you look at this one, x could never equal 0 either, okay? So it can't equal either one of those 2 answers. So let's go through and finish it. And 7 times x is 7x. 5 times x is 5x. 5 times a negative 2 is a negative 10. Move my 5x over, because remember, we are solving for x, so we're going to get x by itself. So I get 2x is equal to a negative 10. Divide by 2. And this tells me that x is going to end up equaling a negative 5. You okay? Can I have that? Can I get that? Yeah, I can have that for an answer because it doesn't match my other ones up here. So when Hawks asks you for an answer, you just simply type in a negative 5. So far, so good? Not so bad on these. These are kind of the easier pieces of knowing what stuff you end up going through and multiplying things through. Okay, so the other piece that they put in there is or do we need to do another one like this? You guys okay? Okay. Is they give you some story problems, so let's get your sheet that you had, and I put them all on here so that I end up having them, so I don't have to write them all out for you. Might be a little easier to read this instead of me writing them all out. It takes a little while to do that. So, the very first one in here says if it took 9 hours to drive to your cousin's house, how long would you estimate the drive to Disney World? The distance to your cousin's house is 333 miles. The distance to Disney World is 740 miles. So out of this, since we're in the proportion methods here, we need to take a look at this thing and say, how can I write that as a proportion? So within proportions, you need to look at things that give you labels. So if you're doing a story problem, we need some labeling type things. Well, what type of stuff is in here? Well, we know we've got 9 hours, okay? And how long did it take to get to our cousin's house?
9 hours.
Did it take 9 hours? Okay, 9 hours drive to your cousin's house. How long would you estimate the drive to Disney World? How long is it going to get me to Disney World? That's my X. Yeah, that's my unknown. Okay. The distance to your cousin's house is 330 miles. Miles included. The distance to Disney World is 740 miles. So what relates to what? So in proportions, we got to relate things to each other. Well, yeah. 9 hours relates to how many miles to your cousin's house. And Disney World, well, we don't know how long it's going to take us to get there. But we know how far we're going to drive. So what would end up being my answer? Well, this is kind of just a straightforward proportion. Do I have to be careful with what my answer comes out to be? Notice these denominators in my fractions are solid numbers, so it has no effect on what x could possibly come out to be, so I can't limit myself with what I have. And so what's my answer? So 9 times 740 equals 333 times x. And then what I want to do with that piece is I want to divide everybody by 333. And so what do I find x to be? What was it? 20 hours. So you better plan to have multiple drivers if you're going to drive 20 hours right through. Okay? So it just kind of depends on which one you got going. All right, makes sense? Okay. Now the next one is pretty much the exact same as that top one, but I think we're okay with it, aren't we? Because we've got 6 hours and how long to get to Las Vegas. So this is my x, that's my 6 hours. The distance to your brother's house is this. The distance to Las Vegas is this. And so I think we can just set that one up as 6 hours over 276 is equal to the Las Vegas hours over 1,380 miles. And so that becomes our two pieces. All right or not all right? We're good? Hopefully. Okay, good. The last one, and of course this one you can solve. 6 times this divided by 276 will give you your answers. Is it 30? Okay. So you get 30 hours out of that one. Okay, if we go down to investments here, Frank's investment. Frank is investing his money. He thinks that he should make $15 for every $100 he invests. How much does he expect to make on an investment of $900? So, what are my pieces to this one? Oh, he thinks he should make $15 for every $100. This is my first rate because it's $15 for every 100 he invests. So then, if you read on, how much does he expect to make for an investment of $900? Where does the 900 go? Top or bottom? Bottom. And we put X on the top. So what would be my final answer to this one? So it would be 15 times 900. Oops. Is equal to 100 times X. Divide by 100. And we end up canceling. We can cancel the 900 and that if you want to. If I have 15 times 9, $135 is what I estimated it to be. Is that right? Yep. Okay. Good deal. Now that's the extent of your story problems that come up in 7.4. Questions on these guys? I don't think they give you anything different than what we had here, so I think you should be okay with that part. All right. Then the other section that they put in here is similar triangles. And in similar triangles, what they will do is they will give you two triangles, and they will tell you that they are similar to each other. So A, B, and C for one triangle. The next triangle that is similar to it might be labeled D, E, and F. So they're similar to each other because both are right angled triangles, and your sides match. Now if I look at this, AC is matched to what? DF. Whoops. And AB is matched to DE, and CB is matched to FE. Okay, so we know those sides all match and they all connect to each other, and these angles in here are exactly the same size. So if this is 40 degrees, this one's 40 degrees. If this one's 50 degrees, then this one is 50 degrees. So your angles also match in there. So you got combinations that are the same. So if you want to do a proportion based on this, we could say AB is in proportion to DE, the same as BC is proportion to EF, because we agreed, didn't we? That those sides all matched each other. And so, whoops, I moved up, sorry. And so the stuff that you have in there is your pieces that you have for your triangle. And then you could also say that AB and DE match, and they match to AC and AF, okay? So any kinds of combinations that you possibly can see in there, but always be careful and match side to side when you're doing those. And so then what they do is they go through and they give you maybe some other triangles in here. And they may say this triangle ABC, and it matches triangle DEF. But instead of just giving you values in there, they might say that this side is x minus 4, and this side is 6. And they might tell you this is 10, but that's x. So how can we figure out what our side measurements happen to be? Well, if we get some comparisons in here, x minus 4 is compared to 10. We okay with that part? Compares to 10. And 6 compares to x. And so we end up with that for our proportion. And our proportion, now this looks like what we just started this section with in solving it. So x minus 4 times x is equal to 10 times 6. So I get 60 over here. X times that is x squared minus 4x. Move my 60 over. That leaves me with x squared minus 4x minus 60 equals 0. Now your favorite thing of all we've been doing in chapter 7, what do I have to do? Factor. Yes, good old factoring. So what does this thing factor to? So I get x and x. What are some factors of a negative 60 that give me a negative 4? What was it? Negative 10, yes, and a positive 6. So what could I say about my sides? Well, if I set each equal to 0 and I add 10, I get x equals 10. If I take x plus 6 and set it equal to 0, I get x equals a negative 6, but what's wrong with that one?
Can't get a negative 6.
Because?
Triangles are not negative.
Right, it's distance, yeah. So the side of my triangle cannot equal a negative value, right? Okay, so since it can't equal a negative value, then I can't have that for my answer, all right? So now what do they want with these two triangles? Well, they want to know what my sides would be. So if I know that I can't have a negative 6, but I can have 10, what's the side of this AB? So what AB is going to end up equaling x minus 4, or 10 minus 4, which equals 6. Okay. What would side FE equal? Or EF, I should say. EF would equal X, and X happened to equal 10, so its side would end up equaling 10. So it will ask you what sides you have in Hawks. It'll say what side is AB and what side is EF, and what's your values for that. Okay or not okay? Questions? Now don't hesitate to ask questions. Just because we're sticking this on tape, you can still ask questions. So with those, what do you think? Okay with?
10 or 8.
Where did I get 6? Okay, because AB is X minus 4. So when I take X minus 4 and I put 10 that I found down here in for X, I subtract 4 from it and I get 6. Okay, so that's where. Alrighty, good. Well, hey, it's a good question to ask. Need to do another one of those, or you okay? Okay or not okay? I'm not hearing anything. So maybe you are. Maybe you're not. They do end up giving you, with these triangles, ones that have 10, 6, and 8, and they give you another triangle that is DEF, but in DEF they give you 11 and X and Y. Now when they give you triangles like this that you happen to have, you got to be careful because it's going to ask you to solve 2 ways. So solve for X and solve for Y. So how can I do that? Well, I got to look at combinations here that are going to let me get to this X. So one combination is 10 is to X, as what would be our other combination that would give me straight numbers, because I don't want to use this Y because I can't put a Y in there because I can't solve for 2 variables at once. 8 over 11. So you want to look for combinations when you've got one missing here that goes with that missing one, but you also want to look where you have straight numbers, 8 and 11. So what would my answer be? So 11 times 10 is 110 equals 8x. Divide by 8, and what does x come out to equal? One more time? 13.75. Okay, 13.75. Okay. What is y going to come out to equal? So, kind of want to do the same kind of thing again, but this time I want to look for combinations that go with y. 6 goes with y, 6 over y, and what else do I want to use? 8 over 11 again, because it's my only full numerical side. I could have put this one back in to where x is at and used it, but it probably wouldn't be as easy as using this value. So 6 times 11 is 66. Y times 8 is 8y. Divide by 8. And what do we find y to be? 8.25. Okay. And that's my 2 pieces that I was missing. All right? Okay, good deal. Okay, so that takes us through that whole section of what we had to have in that part. Okay. Technology. I hate technology sometimes. Probably wiped out a whole section in there, I bet. I bet it did. Okay. Well, anyway, let's do another one of these guys. Any of them that you have that come out looking like proportions, you can do them like proportions because they do run across and put some of those things in here and having those come out. So let's look at this one. 1 over x equals 2x over x squared minus 16 minus 1 over x minus 4. I think you always get something started brand new and you have all kinds of issues with things starting out with recording. So if that missing piece in there, I bet it probably is missing. So I need a LCD. So what's my LCD going to be? So x minus 4 times x plus 4 is what this factors to. X is here, x minus 4 is there, so what's my LCD going to be? So remember, you need everybody from the first one, so I need the x. None of this matches that x, so I need all of it, x minus 4 and x plus 4. And the last one is an x minus 4. Do I already have it in my LCD?
Yes.
Yes, so I don't need it. Okay. So I'm going to take all of this whole thing and I'm going to multiply it by this and find out what each piece gets multiplied by. So what does 1 get multiplied by? X minus 4 and x plus 4. We okay with that? Okay. What does 2x get multiplied by? X. And what does the negative 1 get multiplied by? X and a x plus 4. Okay, you okay so far? Remember again, all denominators, when you're doing this method, all denominators disappear. They are not there anymore. So now I gotta just multiply everything together. So I gotta FOIL this part, so 1 times that's gonna be that. So x times x is x squared. A positive 4x and a minus 4x are gone. And a negative 4 times 4 is a minus 16. 2x times x is 2x squared. Negative 1 times x is a negative x times x plus 4. So what happens with that? Negative x times x is a negative x squared. Negative x times 4, negative 4x. Combine like things on the left. 2x squared and an x squared, or negative x squared is an x squared, minus 4x. Stick all of them together, because remember we need to set equal to 0 to solve it. So, minus x squared. Add 4x. So the x squareds are gone, leaves me with 4x minus 16 is equal to, these guys are all gone, so it equals 0. Pull out a 4, leaves me with x minus 4. Ignore the 4, we learned that before that we can't use that 4 at all, but I can take x minus 4, set it equal to 0, and find x is equal to a positive 4. Can I have a positive 4? If I go all the way back up here, what happens? Here I'm okay if I put 4 in there, right? Am I okay here if I put 4 in it? 4 times 4, because I square it, is 16, and 16 minus 16? No way possible, right? If I put 4 right here, what happens? 4 minus 4 is 0, so guess what? This one has no solution. So some of them, you'll get all the way to the very tail end of them, and they have no solution because you can't end up going through and coming up with stuff out of them, all right? Because it won't let it happen, and you can't come up with what your values happen to be within those. And so be careful with that, and make sure that you're watching for no solutions once in a while. So they do pop up in there when you're doing those. Another one? Yes? Okay, we'll do one more, and then we'll put this thing on pause again, and then we'll take a break. So here's your next one. So x over x plus 4 equals 1 over x plus 1 minus 3x over x squared plus 5x plus 4. Usually they're kind of kind to you in Hawks, because usually if you have something like this that you're factoring, guess what it's going to factor to? Yep. Usually the other pieces that you're looking for is what it factors to. So what's my LCD? So I need everybody from the first, everybody from the second, and the half, so I don't need to add anything else to it. So we're good with that part, right? Okay. So now what? Yep, clear out denominators. So x plus 4 and x plus 4 cancels, so good old x on top gets multiplied by x plus 1. Okay? What does 1 get multiplied by? X plus 4. What does 3x get multiplied by? 1. Yeah. And so, do our math. X times x is x squared. And then minus 3x. And so, combine things.
X and a negative 3x is a negative 2x plus 4. Move everybody over, because remember we need to get it set equal to 0. And I get x squared plus 3x minus 4 equals 0. Yep. In the world does it factor to? Well, x plus 4, x minus 1. So, x plus 4 equals 0 and x minus 1 equals 0. So I add or subtract 4. That equals a negative 4. Add 1. X equals 1. And can I have those? Yes or no? Negative 4, if I put that back in, I can't have the negative 4. Put it in here, 1 plus 1 is 2, and 1 plus 4 is 5. 5 times 1 is 5. So yeah, I can have 1. So my answer is simply 1. Alright or not alright? Maybe. Yes. Yep. Yes, the question was, can I have negative numbers in these for negatives? Is because we're looking with distance. We're looking at a side of a triangle. So you couldn't have any negatives with that, but, yep. Okay. Alright. Alright, let's pause this guy. And we are ready to start 7.5. And 7.5 is all story problems, okay? And we're going to work through as many of these as we possibly can to give you an idea of what comes up with these, because I think the more we practice, and you find that you're going to need to read it a couple times. And while you're reading it, identify the type. And in this section there are 3 types. There are distance equals rate times time problems. There's work problems. And the other is just basic, okay? So there's 3 different types. Step 2 is set up a variable for the unknown. So identify that. Sometimes you're going to want to make it so it means something. Like if you're talking about a river problem, so you might want to make current equal to C, so you know that is the current of the river, okay? So you might want to get some ideas on what type of labeling. Now in Hawks, they are very specific in Hawks, and sometimes they say only use X's and Y's, so be real careful with that. But if you do that, putting the C in there, it makes to what you're setting up. Step 3 is draw a diagram.
And you're going to want to use the diagram with these distance equals rate times time, because you can set up a chart, and in your chart you can have distance, rate, and time, and so that you can see what happens in there and what type of stuff that you have. So sometimes you do want that diagram. It's going to help you out a bit. Step 4 is form an equation. Now these equations that we're going to solve are going to have rational values in them. There's going to be fractional pieces in them. So be aware of that you're going to get some fractional stuff in there. And then step 5 is, of course, solve. And step 6 is check. Always check it to make sure it sounds right. Does it sound reasonable? If you find that your current's going faster than your guy can paddle, you know something's wrong, okay? Because if the current's going faster than he can paddle, what's going to happen? He's not going to go anywhere, okay? The current's going to always force him back, so be extra careful with those. And so that's your ground rules for what we set up with these things. So let's go and see if we can take a look at some of this stuff. And let's go through to your story problems that I handed out to you a little bit earlier. And so then I'm not writing all this stuff out, and we can see what we happen to come up with for these. So the first one that I have up here for you to look at is what is considered to be a work problem. Now, work problems are ones that contain some kind of work that somebody's going to be doing. That somehow you got to figure out how long it takes someone to do a certain thing, but not always are things mentioned to you and what you have. Now, if you have a work problem, the thing you want to keep in consideration with that is you want the time spent per 1 unit. The time spent per 1 unit. Okay, that'll make more sense in a second here. Units meaning hours, minutes, days, whatever the single value happens to be. So if we take a look, and let's read through our problem first and just get an idea of what it says. It says a man can wax his car 3 times as fast as his daughter can. Together they can do the job in 4 hours. How long does it take each of them working alone? Okay, so what do we know? Well, we know we have a man, right? And we have his daughter, right? We all agree on that part? Okay. What does this first sentence tell us about the man and the daughter? It says a man can wax his car 3 times as fast as his daughter. All right, now we're in algebra, so what do we have to know? We have to know that one of these we don't know anything about, right? Who don't we know anything about? The daughter. So we are going to make the daughter X, okay? And what are we going to make her dad, or the man in this case? 3X. We all agree? Okay. Reading on. Together, they can do the job in 4 hours. Perfect. Okay. So, how long does it take each of them working alone? Well, we don't know, because we don't know how many hours it's going to take him to do the car all by himself, and we don't know what she's going to be. Now, is this right? Is the man 3 times, or is the daughter 3 times? Do we have that set up right? A man can wax the car 3 times as fast as his daughter. Three times her speed. So if she waxed the car in 4 hours, he would wax the car in 12. Does that sound right?
No.
3 times as fast. What happened? Do we have this set up right? No, because really it's the man that needs to be X, and the daughter takes 3 times as much. We okay with that? Okay, so be real careful on setting that up. Now, as I set up here, the time spent per 1 unit. Well, what's my unit in here? Well, my unit is hours, okay? So every hour that each of these work if this were broke up into single hours, how much would get done in that hour value? Well, it would be 1/4 of the time would be used to do that car, correct? Correct? Okay. If we look at the man, he's going to be 1/x. And if we look at the daughter, she's 3/x. We okay or not okay? Because 1, 1, 1, meaning 1 hour of time. So we're going to split this thing into each individual hours. Because if this were 6 hours that it took the man to wax the car by himself, 1/6 of the car would be waxed in 1 hour. Okay? So 1x of the car will be waxed in 1 hour. And 1/4 of the car would have been waxed by both of them in 4 hours. Okay or not okay? Yes? I'm not hearing anything. I'm hoping. Okay. So what does this mean? So how long does it take them to work alone, but how long does it take them to do the job if they work together? So we're going to take 1x plus 1/3x is going to equal 1/4. So we get it set up so it's on an hour basis. So if we solve it, what's my LCD for this whole thing? X, 3x, and 4x is going to give me LCD. Well, we know we got an x, right? But what about numbers? You have a 3 and a 4. Yeah, I need a 12. So 12x is my LCD. So x goes into 12x 12 times. 12 times 1 is 12. So now we're back to doing what we did in 7.4b. 3x goes into 12. 4. 4 times 1 is 4. 4 goes into 12x. 3x times. Okay? So 12 plus 4 is 16. So if 12 plus 4 is 16, what does it take them to wax the car by themselves? So if I take 3 and divide it into 16, the dad can do the car all by himself in what was it? 8 hours straight? 16 divided by 3 is 8? Yeah, 5 1/3 hours. Okay? How long does it take the girl to do the car? So the daughter, this is the man, the daughter, how long is it going to take her to do the car? So 3 times 16/3, these 3's cancel, so I'm left with 16 hours. So if he does it all by himself, it's 5 1/3 hours, and if she does it all by herself, it takes her 16 hours. Okay. Takes a while to wax that car, right? Yes or no? We okay? Or not okay? Yes? Okay. Where did I get this 4?
No, the 12 plus 4 equals 3x.
12 plus 4 equals 3x. I took 12x times this part. X goes into 12x 12 times, because the x's will cancel. 12 times 1 is 12. 3x into 12x goes 4. 4 times 1 was 4. I'm building equivalent fractions, or clearing out my denominators. Okay, so I'm actually taking this and timesing it by here, and timesing it by there, and timesing it by there. Okay, so it's being multiplied by each piece separately. All right. This one. Now again, these are ones that pop up in your certify and in your homework and in your practice parts of what you happen to run across. And in this case, what do we have happening? Well, it takes 60 years for, this should be a 4, sediment to fill a channel. Funds for dredging are not always available, and the environmental impact study puts the dredging rate at 1/240 of the canal per year. How many years before the canal will be filled with sediment? So, what in the world we got in this thing? So, it takes 60 years of sediment to fill the channel. all right? But what do? They do dredging, but they're not very good at their dredging, and they dredge at a rate of 1/240 of the channel per year. Is that very much of a channel? Who knows how long the channel is? So what that means is if this is my channel, they're dredging 1/240 piece of that channel every year, okay? So they're dredging pretty slow. So how many years before the channel will be filled with settlement? So how many years is it going to take? So they're slowly dredging stuff, but they're kind of fighting it back a little bit, but not fighting it back as much as they could. And so they dredge at 1/240. And X is going to be till it's filled. So what can I make out of all this? Well, if I base it on per year, this is already per year. 60 years, if I make it per year, is 1/60 because it's 1/60th gets filled if I leave it at that. This one's already figured. What's this one per year? Well, we don't know what the numbers of years are, but if I want to make it per year, basically all you're doing is taking your base values, putting them over top of 1. And this one's probably one of the tougher ones that you run across in here. So if I set it all up, I'm going to have 1/60. But what happens when you dredge? What does dredging do? I know what dredging does. Dredging takes sand out. Decreases. Good deal. So that's a minus. And that's going to equal 1/x to fill that whole channel in. And so we've got a subtraction piece happening in there. So what has to happen? So if I do this, I need an LCD. What's my LCD going to be? Between 60, 240, and x. Well, we know we need an x. 60 and 240? 60 goes into 240, doesn't it? Yeah, okay, so I can use 240. So 60 goes into 240, 4x times, we all agreed, times 1. 240 goes into their x times, and 240x and x, this leaves me with 240. So 4x minus x is 3x. So divide by 3, and I find x is going to take 80 years to fill the channel in completely. So do the people of the city say, great, it's going to take 80 years, what do we care? What do you think? Should they say that? Probably not. They really shouldn't say that, because if they said that, then what's going to happen? Maybe they'll be dead and gone in 80 years, but somebody else is going to have problems, okay? And so that becomes a problem. Our Great Lakes are having problems right now because of the Great Lakes. You've got all of the areas because of the lack of water they're having problems with, so they got a lot of dredging going on in different places. The other kind that fits into work is this one. It says an inlet pipe on a swimming pool can be used to fill a pool in 36 hours. A drain pipe can be used to empty the pool in 49 hours. So what does that mean? So fill the pool in 36 hours, drain the pool in 49 hours. So far so good? Okay. Reading on. If the pool is 2/3 filled and then the drain pipe is accidentally opened, how long from the time will it take to fill the pool? So to fill the pool, working together, what's going to happen? If they're working together, how long does it take the two working at the same time to fill the pool? Do we know? No, that's X. So with this one, it's a two-parter. The first part is find out how long it takes if they were both open at the same, if the one was filling and the one was taking it out at the same time, how long would it take to fill the pool in that situation? If somebody left the drain pipe on when you just started filling the pool. Not very wise to do, right? So we have 1/36 plus 1/49 is equal to 1 over x. We okay with that part? That's kind of the main setup with this one, is that you've got those pieces in there. So I need an LCD. Easiest part of the LCD is I need an x. What do I need with 36 and 49? I don't think anything goes into either of those, does it? I don't think there's anything in common. 7 doesn't go into 36, and that's the only combinations that I have. So 36 times 49, what do you guys end up with? 1764. Whew, big thing. So 36 goes into all of this 49x times, correct? What does 49 go into all that? 36x times. And x goes into there 1764 times 1. Okay, what comes out of that? 49 and 36 together. What adds to that? 39 and 46 gives me, what was it, 85? Yep. Divide both sides by 85, and I find if they all work together, it's going to take how many hours? 20.75. Okay, good deal. Okay, so we get 20.75 hours if you left both things on. But what did it tell me up above in my problem? It told me that the pool's already 2/3 full when that happened. So how many hours after that would it take? So if I take 20.75, this is part 2. If I take 20.75 and times it by 2/3, what will I end up being left with for hours? So 27.5 divided by 3 is going to give me, oh actually no, I need to multiply by 1/3 because there's only 1/3 of the pool left. That would give me how many hours it take to do 2/3. But 1/3 is left because 2/3 from a full pool is 1/3. So what's 1/3 of that? So 20.75 divided by 3 will give me, what was it? 6.92 hours to end up filling that pool.
Is that a plus sign or a multiple?
Oh, this should be a times. Yeah, that's a multiply. Sorry. Yeah, multiplication. Yeah, need to make it bigger, I guess. Needs to be a multiplication happening there.
So that would be the answer.
Yep, 6 hours and 6.92 hours to fill the pool. Okay, what do you think? These are work type problems. So we got work issues, and then the next group that you get, and again, with these work ones, make sure that you always go through and look at your time spent per unit. And again, we worked out some of the more difficult ones. These two are tougher than the top one. Okay, so we did work on some of the harder ones. The second variety of problems is distance equals rate times time. Okay, distance equals rate times time. These you are going to want to put together a chart, and in your chart you are going to have distance equals rate times time. And when you look at these, you're not always given all of your pieces, okay? You're going to have something that might be missing. And in many of them, you have 2 possibilities of things that are happening. In fact, in all of them you do. And you have to look for the information that you happen to have to fill in your distance equals rate times time. Now, if you have to solve, and in most cases, if you have to solve for time, how do I get time by itself? Well, if I've got distance equals rate times time, and I divide by t, or divide by r, sorry, get my time alone, T ends up equaling distance divided by rate. We okay with that part? Okay, because all I did was to get T by itself here, divided both sides by R, and I got T equals D divided by R. Okay, so if we look at the very first one in here, a man can row his boat 5 miles per hour on a lake. So what do we know about lakes? Lakes have current? Lakes are just lakes. The only thing that makes a lake have any difference in it is the wind, and as the wind pushes on things, you've got a difference in there. But if you go to a river, it says on a river, it takes him the same time, notice how it says same time in here, to row 5 miles downstream. What's happening if you roll downstream? Those who canoe, what does it do? Yeah, riding with the current, so you're going to go faster. Yeah, that's why when you go to a canoe livery and you rent a canoe, they send you downriver because, of course, the canoeing is a lot easier than canoeing upriver. So what do they usually do? They drive a vehicle around and pick you up. Okay, so if they pick you up, then you don't have to paddle back upstream. But in his case, he's going to go downstream as it does to row 3 miles upstream. So he's kind of one of those, must be an avid canoeer because he's going to row upstream as well as rowing downstream. And so there's a difference there. It says, what is the speed of the river's current in miles per hour? So here's my chart. So what do I find in my chart? Well, I'm going to break it into 4 parts because I have distance, rate, and time. And if I plug my pieces in, I have downstream and I have upstream. So what do I know about them? What do I know about my distance? If I paddle downstream, how far do I go? 5 miles. Okay. If I paddle upstream, how far do I go? 3. Okay. What about my rate? Oh, what do they tell me about this guy? Well, they tell me that in a lake, he canoes at 5 miles per hour. So what happens to his rate of speed if he canoes downstream? It's going to what? What's going to happen if he canoes downstream? The current is going to make him go faster. We all agreed that, didn't we? So his rowing speed plus the current speed is going to make him go faster. We okay with that part? Okay. What's going to happen if he canoes upstream? We know he can paddle at 5 miles per hour, but as he's paddling, what's going on if he's going upstream? What's the current doing to him? He's fighting the current, and so the current's going to have an effect of taking off some of his speed. You okay? You okay with that part? Okay. Now what do we know about time? What do we know about time? It says the same time, so what that means is that these two are going to be the exact amount of time, but do we know what they are? Not a clue, okay? That's where you take these and solve for t. Remember, this is times in there, so to do that, if I solve this one for t, the top one, I'm going to take 5 and divide it by 5 plus c to get to time by itself. If I do upstream, that's going to be the distance divided by the rate, which is 5 minus c. And so now what do I find? The times are the same, so those two rational values end up being equal to each other. And then we're back where we were with proportions to solve it. Okay, you guys solve that one on your own? What do you think? Because basically you take 5 times 5 minus c is equal to 3 times 5 plus c. And we might as well finish it so it's on the tape here. 5 times 5 is 25. 5 times negative c is a negative 5c. 3 times 5 is 15 plus 3c. Get all my c's together and all my numbers together. So I'm going to minus 15. And I'm going to add 5c. So when I do that, I'm left with 10 is equal to 8c. Divide by 8, and I find out my current is equal to 10 divided by 8, or 1 and 2/8, or 1 1/4, or 1 2/8. Yes, 1 1/4, 1.25 miles per hour is the speed of the river. Not a very fast river, but it's got a current to it. Yes or no? What do you think? Okay, let's do another one of these guys.
Wait.
Whoops.
Why did you add 5C instead of add 3C?
Because it would have been come out negative. If I add 5c to this side, my c's stay positive.
Okay.
If I would have took away 3c, I would have had a negative. And then I would have had to move 25 over, which would have made it negative, and everything would have been negative.
Okay, so you wanted the C's all by themselves and
Yep, want c all by itself. Yep, get c alone. Okay, let's look at the next one. It says if a passenger train travels 3 times as fast as a freight train, and the freight train takes 4 hours longer to travel 210 miles, what is the speed of each train? Distance equals rate times time again, because it's a traveling thing here. Distance, rate, and time. We have what kinds of trains? We have a passenger, and we have a freight train. And what do I know about their rate, about their speed? It says if a passenger train travels 3 times as fast as a freight train. What does that mean about his rate? 3x is the passengers. What's the freight? Is x. Okay. Correct. Alrighty. So if that's what we got for our 2 values in there, what do we know? Well, if we look at this, keep reading, it says a freight train takes 4 hours longer to travel 210 miles. What is the speed of each train? How far are they traveling? Yep, so our distance is 210. Okay, so we know that ends up being what our distance happens to be. What do we know about time? Okay, so how do we fit that 4 hours? Can we fit that in there? That's where the trickiness of this thing comes in, because I can't just put 4 here, because it's not 4 hours for the passenger train and it's not 4 hours for the freight train, but it takes it 4 hours longer to travel. So what would you do? What was it? X plus 4? But how can I put more variables in here? X is meaning my speed, right? So if I put X with time, I've got a problem in there. So 3x times x? But x isn't representing time anymore, it's representing my speed. So we've got to still get our time figured out based on taking this and dividing it by that. So my time in the first one is going to be 210 over 3x. The time in the second one is going to be 210 over x. But what is happening to these 2 trains? And if you look at them, if you look at this rate, the freight train is going slower than the passenger train, correct? So if the freight train's going slower, and we subtract the passenger train's speed from that, so 210 over 3x, the difference between these, it takes this train 4 hours longer than this train, correct? And so then if you set that equal to 4 over 1 for the amount of hours that you end up taking, you'll end up getting your correct solution with that one. And so then you can be careful with these. There are some that involve subtraction, and usually they're the ones that involve this 4 hours longer or shorter or those kinds of things, that you end up with subtraction ones in there. So then we could end up solving this thing, and if we solved it, our common denominator would be 3x. Or if you looked at that, you would notice that it would reduce, but we aren't going to reduce it. We're going to just multiply by 3x. X goes into 3x 3 times. 3 times 210 is 630 minus 3x goes in there minus 210, and 1 is 3x times 4 or 12x. So 630 minus 210 is going to give me 420. Divide by 12, and we find that x is going to end up equaling what? What was it? 35. So what does this mean? Well, it says what is the speed of each train. So the freight train is traveling at 35 miles per hour. We okay with that? And what is the passenger train traveling at? 105. Because 35 times 3 gives you 105 miles per hour. So that would be your two answers you would type into Hawks. Be careful and make sure you put them in the right spots. If you put the passenger train traveling at 35 and the freight at 105, you got a problem, okay? So be really careful with that. The last variety of, and I'm not going to get through a bunch of these, but the last variety is just the normal, regular, run-of-the-mill type. And in this case, it says the denominator of a fraction is 2 more than twice the numerator. What does that mean? The denominator of a fraction is 2 more than twice the numerator. What did we get? So the denominator is 2 more than twice. So 2x plus 2. And what's the numerator? I know what the numerator is? Numerator is x, because I don't know anything about it. It says the denominator of fraction is 2 more than twice the numerator. 2 more than twice x. Okay. If both the numerator and denominator are decreased by 4, I gotta get the rest of my problem up here. I guess I didn't realize it got split. Is reduced by 4. What does that mean? Reduced by 4 or decreased by 4. What does that mean?
Both ones are subtracted by 4.
So both the numerator and denominator get a minus 4 on them. The result is 5/13. Find the original fraction. Do not simplify. Be careful with that because it makes you want to think you got to simplify it, but leave it as it is, and whatever comes out of this, don't reduce it, don't do anything to it of what happens to come out of that problem. So I got to do some work here because I got x minus 4 over 2x minus 2 plus 2 minus 4 is a minus 2. That's where I got that minus 2 at. We okay with that part? I just combined them together. Over 5 over 13. Proportion. So 13 times x minus 4 is equal to 2x minus 2 times 5. Finish it. 13x minus 4 times 13 is 52. 2x, or 2 times 5 is 10x. And 2 times a negative 2 is a negative 10. Put my x's together, so minus 10x. Add 52. Gives me 13x is equal to 42. Divide by 13. So my answer for x comes out to be 42 over 13. Oh, 3. Thank you. Yes, I'm subtracting and not. Whoops, that's a minus 10. Put that back in there. Yes, it is 3. And it said don't simplify. So I would just simply leave that as 42 over 3. Okay? And so that would be my answer for what x happened to be.
Your x is 14.
What was it?
X equals 14.
what was it?
X equals 14, and you take 3 divided by 52.
Right, but it said don't simplify. So be careful, it says do not simplify. So, right. Yep, leave it as it is. That's a funny thing. I put in the other one and it gave me a wrong answer because I reduced it too and said 14, great, I can put 14 in there, and boom, I got nicked. Okay, so be careful with that and watch the ones you got there. Okay, now you've got other ones in here that is kind of ends up being a mixture of different types of story problems that, of course, we aren't going to get a chance to get to some of these in there. We got time to set up one more. What kinds would you like to set up? What ones do you think was your toughest? Was it the motion or the work ones, or the distance equals rate times time, or just the general ones? What do you think? Because we got time to do one more. What kind would you like? Distance equals rate times time? Okay. Airplane. I think you can find that one. It says an airplane can travel 405 miles per hour in still air. If it travels 1,287 miles with the wind, in the same length of time it travels 1,143 miles against the wind, what is the speed of the wind? So, we got to chart all this thing out here, because we've got with wind. What's that going to do if it travels with the wind? Yep, it's going to travel faster. So distance equals rate times time. So it's going to travel faster. And if it's against the wind, it's going to travel slower, of course. So in still air, it's 405. So with the wind, against the wind, that's my rates. We okay with that part? Figuring out our rates? Yes or no? We good? Okay. And then, if we look at distance, how far does it travel if it travels with the wind? Yeah. And if it travels against the wind? Okay. That's why sometimes when you fly in an airplane, they'll say, oh, we're getting into Dallas 20 minutes earlier. It's because of these winds. If you get a tailwind, you're great. If you get a headwind, you may not make it to your next gate. Okay, so that's the reason they always tell you that when you get to an airport, is that you got those differences. So then time is just taking the distance, dividing it by the rate, and doing the exact same thing with the other one. 1,043 divided by 405 minus W, and we end up with what when we solve this thing? So it's going to be this times that is going to equal the opposite times the opposite there. So 405 plus W times 143. Good experiment on using your calculator with this one, because you get some pretty big numbers in there as you're working it through. So I think this comes out to be something like 5,000 or 521,235 minus 1287W. And on the other one, it's 462,951 or 915, sorry, plus 1,143W. Get all my W's together and all my numbers together, and that ends up being something like 58,320 is equal to 2,430 W. And then last of all, divide this into that, and we find out the speed of the wind to be 24 if you divide those two together. So that's what happens to that one. Okay or not okay? Okay, now that gets us to the end of that section, so, that's where that part stops.